Hello everyone and welcome back to Diksha Karnataka YouTube channel. Today I am going to discuss the KCET Premier League paper number 12. So already we are almost at the end and this is the 12th week and we are doing the 12th KPL match, and today's topic was gravitation and properties of solids, properties of fluids, as well as a chapter from your second PU as usual, that is magnetism and matter. So these are the everything that is there in today's KPL paper. I hope you have solved it, and I am going to reveal all the answers, and I ask you check all the questions if you have solved them correctly or not, and at the end don't forget to let me your score in the comment below. So also I hope you are attempting this question paper seriously, because all of the questions that we are discussing here are either taken from previous year questions or they are most likely very important question. So let's start with today's discussion. So the first question is very simple and obvious. Which of the following graphs correctly represents the variation of G on the earth? So we know that the variation of G on the earth depends on it is directly proportional to the radius when it is inside the earth. So all of the graphs except this one are showing that it is varying like this. Okay, so three of the graphs are showing that variation like this, so obviously this is the correct part, and after it crosses the radius the inverse square law applies, so it reduces like this. So we can say that the correct answer is option B. If you have answered anything else, don't forget to mention that in the comment below and what is your reason behind that answer. Okay, only correct answer is option B. Okay, now what is the value of acceleration due to gravity at a height equal to half the radius of the earth from its surface? Very interesting question. Okay, and if you think the answer is 0, then you are wrong. Okay, you cannot use the shortcut formula that I told you, that is only valid for small distances, for say 10 kilometers, say 20 kilometers, but half the radius means it is 1600 kilometers. So that is not even 1600, 3200 kilometer. We know that the radius of the earth is 6400 kilometer. So if you say half the radius of the earth, that means it is 3200 kilometers. That is not small. So you cannot use the reduced formula, you have to use the actual formula, which says that gravitation at some height h is given by gravitation on the surface of the earth divided by 1 plus h by r whole square. Right, you have to use the original formula. Okay, the formula reduces to 1 minus 2 h by r for small distances. Okay, that is not for higher distance. Okay, so you can write this as G divided by 1 plus r by 2 by r. So at what height? Height is given as half the radius of the earth. So height is half the radius of the earth, right? So height should be r by 2. R is radius of the earth. Okay, sometimes you can use RE, but since we are doing it for an exam, so you don't need to mention everything like this. So what you can do now, what is the value of r by 2 by r? This is very important. Okay, I know many of you struggle to solve this part as well, right? So let me explain. So r by 2 means r by 2, so 2 is in division, and in the division there was one more r. Okay, so these r cancel, so you get half. So r by 2 divided by r is nothing but half. So what is the value? And there is a square also. Okay, so G divided by 1 plus half whole square. Okay, now what is the value? So GH is equals to G divided by 1 plus half is what? 1 plus half is 3 by 2, right? 1 plus 2 is 3 by 2. You can do it using mathematical method, or you can simply understand this and you can write it. Okay, so whatever way you are comfortable with. So G divided by 3 by 2 whole square, that is 9 divided by 4. Okay, now this entire thing is in division. So entire thing is division means this 4 is double division. Double division means it will go up and it will become multiplier, right? So 4g divided by 10. Okay, so 4g divided by 10 sorry, 4g divided by 9, my mistake. Okay, now let's put the value of g. What is the value of g? 9.8. Okay, now instead of writing 9.8, if I approximate this value to be 9.9, okay, then what is the advantage? The advantage is that now we can cancel it using this 9 in the denominator. So we will get 1.1, right? So now if you multiply, it will be 4.4 meter per second square. That is the unit of the gravitational acceleration. So from the given option, obviously the correct answer is option A, directly matching. Okay, this is the approximate value, right? Now let's move on to the next question. Question number 3. A space station at a height equal to the radius of the earth. Okay, so the formulation of the question, the first line of the question is similar to that previous question, but there is a difference. If v is the escape velocity on the surface of the earth, then the same on the space station is time is. Okay, so v is the VE is the escape velocity on the surface of the earth. The same on the space station is dash times VE. So how much is the multiplier? So the multiplier you want to find. So what is VE? On the surface of the earth, we know that gravitation, the escape velocity is square root of 2gr. Right, here r is the radius of the earth. Now they have said that the space station is at a height of equals to the radius of the earth. So the space station is rotating at a distance 6400 kilometers, that is radius of the earth. So what will be the escape velocity there? So suppose the escape velocity there is VE dash. Okay, so what all will be different there? First of all, there the gravitational acceleration will be different. Okay, g dash say, and this radius, this is on the surface of the earth. So what will be this value? This value will be r plus r, right? So at a distance r from the earth, so this will be the new distance. You have to add that distance, right? Clear? Now we have to calculate g dash. So with last problem only we have seen that g dash is nothing but g divided by 1 plus r by r whole square. Why r by r? It is h by r. So instead of h, I have substituted r directly. Okay. So just if you have any doubt, you can check the previous problem, understand it, and if you have understood, then you can solve it directly without using the same variable again and again. So it will be this r and r cancels, so you have 1, so you will get g 1 plus 1, that is 2 whole square. So it will be g by 4. Now let's insert everything here. Okay, so what we got? We got 2 g by 4 times 2r. Right, now let's cancel one of the 2r, so there will be one extra 2. Now let's take this 2 outside. So if I take this 2 outside, it will become 1 by root 2. Why 1 by root 2? Everything was under a square root. Okay, so if you take anything whichever is under the square root, take outside, then the square root you have to take with it, right? So now whatever is left, we have 2gr. Okay, this is already taken care of, so this 4 is already cancelled, this 2 is already cancelled, so and whatever left over 2 is, that is taken care of. Now you should have said that, sir, why didn't you cancel? You will realize that this root gr is nothing but escape velocity on the earth. Okay, so that's why I have not cancelled that extra 2. So you will get VE by root 2. So it will be 1 by root 2 times the escape speed on the surface of the earth. So as you are moving away from the earth, the escape speed decreases, obviously, right? You are already outside earth. So as you are slowly moving away, the escape speed will slowly decrease, right? If you are at infinity, your escape speed will be 0, right? Now, question number 4. A mass m on the surface of the earth is shifted to a target equal to the radius of the earth. If r is the radius and m is the mass on the earth, then the work done in this process is very interesting question. Okay, so on the surface of the earth, what is the potential energy? Potential energy, what is the formula for potential energy? Potential energy, we know that it's Gmm by r. Okay, so suppose we have, this is the earth and this is our object, small object. It is on the surface of the earth. Okay, so what is the distance between these two objects? The distance between these two objects is r, right? What is the mass of earth? Mass of earth is m. What is the mass of this object? This is small m. So what is the potential energy? Potential energy between any two masses, potential energy between any two masses separated by a distance r is given by G m1 m2 by r. Similar to that of electric potential, if you remember, K q1 q2 by r, right? Similar to that, it is also G m1 m2 by r. There is a negative sign, but for the time being we don't need the negative sign, we can just consider the magnitude. Now if you, this is at the beginning, this is u1. Now if you take it to a distance of another r, so this distance is r, then what is the new distance now? The new distance will be, this is r and this is another r, so the new distance will be 2r. That's it, very simple. So u2, so mass is not changing, obviously mass of earth is not changing, mass of the object is not changing, only thing which is changing is the distance. Distance is now 2r. Okay, so how much work we needed? The work done required to do shift it from initial to final position is u1 minus u2. So it will be Gm m by r minus Gm. Don't worry about the sign here, okay? You just need to find the magnitude and then subtract smaller value from bigger value. That's it. So the LCM is 2r. So obviously you will get 2 Gm m minus Gm m. Okay, so we multiplied, the LCM is 2r, so this 2 is extra, so this 2 you have to multiply on both sides. Here it is already 2r, so we cannot multiply anything, so you will get, this will be equals to Gm m by r. Okay, now if you see, none of the answers given here is actually matching with this value. Why? Because you have to convert it into the gravitational acceleration. What is G? G is nothing but, G is Gm by r square, right? These are the things that you need to remember, like you know your fingers, you have to remember everything like this. Okay, if you have spent some time in your first PU, then it would have been very, very easy. If you have not, then you have to learn them now. Okay, so mr. Now what is this? This is sorry, there is also a 2. Let me not write it here, let me write it here. Now this is equals to the gravitational acceleration. What we have done, we have multiplied r in the denominator, 1r in the numerator. Okay, so 1r in the division, 1r in the multiplication, so that extra r cancels. So we can write this as G, so it will be m G r by 2. Okay, so I have sandwiched the G between m and r so that our answer exactly matches with the given option. Okay, so we have solved the question number 4 easily. Now let's look into question number 5. The value of acceleration due to gravity at a depth of 1600 km is equal to So now we are going inside the earth. Okay, so far whatever our problem was, that was outside earth. Okay, so at some height. Now we are going digging deep into the earth. Okay, so what is the formula for that? At some depth d, okay, the gravitational acceleration is g, 1 minus depth by r. Okay, so this is the formula when we are calculating the gravitational acceleration inside the earth. This is easy formula. So what is the value? G, we will put the value of G later. What is the D? D is 1600. Okay, what is the earth? Earth is 6400. Now both of them are kilometers, so we don't need to convert them into meters because they are in a ratio format. Okay, so ratio format, as long as they are in the same unit, we do not need to convert any units, right? This is one of the tips. So we have cancelled the zeros. 4 16s are 64. Okay, 4 16s are 64. So G, 1 minus 1 by 4. So what is 1 minus 1 by 4? 1 minus 1 by 4 is nothing but 3 by 4. Right? Now instead of using the value of G as 9.8, we will use the value of G as 10. Why? That will be helpful for us to cancel. Okay, now 10 divided by 4. 10 divided by 4 is 2.5. Right? So 10 by 2 is 5. Another 2 is 2.5. Okay, so it will be 7.5 meter per second square. Okay, so if you check the options, only correct answer is 7.35 from the given options. Because we have approximated the value, so the answer closest to our approximated value is 7.35. so this is the correct answer. Okay, now question number 6. A period of geostationary satellite is. So what is the period of a geostationary satellite? Geostationary satellite, as I explained, rotates along with us, so that when we are completing one rotation, it is also completing one rotation. So basically geostationary satellite rotates around Earth in the same time that Earth rotates one time. So its period is 24 hours. Okay, so that it appears to be stationary when we observe it. That is the basic thing about geostationary satellite. Okay, the mass of a body is m on the surface of the earth. The mass of the same body on the surface of the moon is m by 6. So those who have written m by 6, I just want to tell you that you are all wrong, because mass does not change wherever you go. Okay, mass is constant, only weight is changing. Okay, because weight is related to gravity, mass is not related to gravity. So mass will remain constant and it will be m on the surface of the moon as well. This is a full question, just a trick question, but very easy question. If you know the answer, if you understood the question, it would take maximum 2 seconds to answer. But if you have not understood the question, then it will take 2 seconds to answer, but it will be wrong. Okay, now question number 8. What is the period of revolution of Earth's satellite? Ignore the height of the satellite above the surface of the Earth. Given the value of the gravitational acceleration, g is equal to 10 meter per second square, radius of the Earth 6400 kilometer, take pi is equal to 3.14. So if you calculate this, this will come out to be 83 point something 73, like that. Okay, so or if you use the correct values, then 9.8 and this as pi as your calculated value, then you will get very close to 85 minutes. Okay, so 85 minutes is the answer for this question. Okay, you can check the formula for gravitational acceleration. Okay, time period. Time period is 2 pi square root of radius of Earth divided by g. Okay, this is the satellite, time period of a satellite, Earth satellite. So basically what we are assuming, the satellite is rotating almost on the surface of the Earth. Okay, almost on the surface of the Earth. It does not have any height. So this is the basic Earth. This is called Earth satellite. Okay, this is an imaginary satellite which is orbiting around the Earth. If it is orbiting exactly on the surface of the Earth, then what would be the time period? Okay, now So that's why it is said ignore the height of the satellite. Okay, if you consider the height of the satellite, it becomes little tricky. Okay, now let's move on to the next question. The length of the wire. Now we are, so gravitation questions are over. Now we are slowly moving into properties of solid. Okay, so from here question number 9 till I think more few questions are based on properties of solid. If the length of a wire is made double and radius is halved of its respective values, then the Young's modulus of the material of the wire, okay, the spelling of the modulus is wrong here, okay, Young's modulus of the material of the wire will be remain same, become 1/8 times, become 1/4 time, become 4 times of its initial value. So what is the answer? So now we know that Young's modulus does not depend on the length or radius of the wire. Okay, it depends on the material itself. It's a constant. Okay, if you apply force, obviously its length will change, and based on that change you can calculate Young's modulus, but it is independent on the shape and size of the object. Okay, it is only dependent on the material, so it will remain same. As long as the material is same, the Young's modulus will remain same. Let's move on to the next question. Young's modulus of a perfect rigid body. Okay, so perfect rigid body. What is a perfect rigid body? What is a rigid body means? What is the meaning of rigid? You may have heard the term in English as well, and it is very common in physics as well. Okay, rigid means which is very stubborn. He is not ready to change. Okay, that is called rigid. Okay, so rigid means if you apply some force on an object, its shape and size will not change. It will remain intact. Its change in its length will be 0. So change in its length will be 0 means we know that Young's modulus is force by area divided by delta L by L. Now delta L is 0. If delta L is 0, okay, no matter how much force you apply, then it will be force by area divided by 0. So in the denominator it will be 0. So the Young's modulus will be infinity. Okay, so Young's modulus will be infinity in this case. Now let's move on to the next question. A wire is stretched such that its volume remain constant. Okay, so the volume of the wire remains constant. The Poisson ratio of the material of the wire is. So first let us understand what is the meaning of the constant volume. So what is the volume of a wire? Volume of a wire generally we consider it is to be a cylindrical wire. If it is a cylindrical wire, okay, there will be a radius of the wire, there will be a length of the wire. Now if you apply some external force on it, it will expand, it will contract, but its total volume will remain constant. So what is the formula for volume? Formula for volume is pi r square L. That is the formula for a cylinder, right? Area of the base is pi r square times the length. That is the basic definition of formula, volume. Right, so pi r square L is the volume in this case. Now volume remain constant. So what is the meaning of that? Differential meaning of a constant. What is the meaning of a constant in terms of differentiation? If we know that it is a constant, then its differentiation is 0. Okay, so if you differentiate this volume, you will get 0. So here what we will do? We will do dV. Okay, like you do dx, here we will do dV. Okay, now here we have two variables. Okay, so in our left hand side we have one variable, on our right hand side we have two variables. So how to do that? First we will keep one of the variable constant. So let me keep L constant for the first time. So pi is obviously a constant, L is constant for the first time, and let us derive the 2r r square. Okay, so r square's derivative is 2r dr. Right, in the second case let me keep r square constant and derivative the L. So derivative of L is nothing but simply dl. Nothing is there, only one L, so it will be dl. So on our left hand side we get 0. Okay, so change in the volume is 0. Change in the volume is 0 means, okay, so dV will be 0. So 0 equals to pi 2 pi RL. Let me rewrite this. So 2 is writing first, then pi, then R, then L, 2 pi RL dr plus pi R square dl. Okay, now let me take everything on this side. So we will get 2 pi R L dr equals to minus pi R square dl. Okay, so basically what we have done, we have written this on the first, then we have taken this on the other side, so that becomes negative, right? So because in between their sign was plus, now since we have changed the sides, it will become negative now, right? Now what else? What is Poisson's ratio now? Poisson ratio is dr by r divided by dl by l, right? This we know that Poisson ratio is dr by r. So what we have to do, first we have to find dr by r. Now what we will do, we will take this pi r square, it is creating some problem, and we will divide it on this side, okay, and here this L is creating a problem, so this L I will take it to the other side, okay. So 2 pi r dr divided by pi r square equals to minus dl by L. Okay, so rest is only some arrangement, some mathematical arrangement, that's it. So now what we are trying to find, we are trying to find dr by r divided by dl by L, that will be equals to minus half. So if you just reorganize this, you take this on the other side, you take the entire quantity on this side, then you will get, this is the Poisson ratio, so this will be minus 0.5. Okay, so the correct answer is minus 0.5. okay, so this will be the answer. I hope you have understood this question, very interesting question. Okay, now we will move on to the next question. Okay, so now the question number 12. Young's modulus is defined as the ratio of, so what is the definition of Young's modulus? So Young's modulus is tensile stress divided by tensile strain, okay, or longitudinal strain. So this is the tensile stress and longitudinal strain, okay. Bulk stress, obviously bulk modulus, hydraulic is also bulk modulus, shearing stress and shearing strain is the Poisson ratio. So shearing stress by shearing strain is shearing modulus, okay. So these are all different modulus, only tensile stress by tensile strain or tensile stress by longitudinal strain is Young's modulus. So this is the correct answer, okay. Now a spring is stretched by applying a load to its free end. The strain produced in the spring is, so you have a spring, and if you apply some force into it, okay, so what will happen to this spring? So it will elongate in this direction, as well as there will be an angular force that will change, that will apply on the branches of the spring. So it will face a angular force as well, angular stress as well, and so we can say that the spring will suffer longitudinal and shear, okay. So the strain produced will be longitudinal strain as well as shearing strain, okay, because the springs are not flat, they have a curve, so there will be a angular strain as well, which is known as shearing strain, okay. So there will be longitudinal strain as well as shearing strain, okay. This kind of questions are unpredictable every year. If they ask you a new geometry, okay, which is maybe very difficult to understand, but if you try to focus your head, okay, you can eliminate the incorrect options, okay. So for example, in case of string, this is not a single straight wire, so obviously it is increasing in length, so longitudinal strain will definitely be there, but since its structure is not simple, there will be shearing strain as well. So you have to identify, okay, what is the twist in that question, and then according to that you have to answer, okay. the ratio of hydraulic stress to the corresponding strain. So I just answered it in our 2 questions back. So hydraulic stress to the corresponding strain is known as bulk modulus. Okay, hydraulic strain happens when you apply force on the entire volume. So the volume decreases or volume gets compressed. So that's why it is called bulk modulus. Okay, not rigidity modulus. Not rigidity modulus is something same as Young's modulus. Okay, compressibility, Young's modulus, they are not making any sense. Okay, because we are talking about the ratio. So ratio means it has to be bulk modulus. Okay, now question number 15. An iceberg floats in water with parts of it in submerged. Okay, what is the fraction of volume of the iceberg submerged if the density of ice is rho I is equal to 9.91 gram per centimeter cube? Okay, so we have an iceberg. I solved this question during our class, if you remember. So we have an iceberg. Okay, and this question is based on Archimedes principle. So you have, suppose the entire volume of the iceberg is V, okay, and the submerged portion of the iceberg is X. So we are trying to find how much percentage of, how much fraction of V is this X. Okay, we know that most of the iceberg generally sinks and only small portion floats above. Okay, so what is the Archimedes principle? Archimedes principle says that whatever is the weight of the ice, so what is the weight of the ice? Weight of the ice is volume, its volume times its density, density of ice. Okay, that is mass times gravitational acceleration, that is mg, right? So this is the weight of the entire iceberg. That should be equals to the weight of the displaced liquid. So how much liquid is displaced? Liquid is displaced is X, because X is submerged into the water. So exactly same amount of liquid will be displaced, right? Now what is the density of water? Here we have an advantage. Okay, density of water is 1. If it was any other liquid, then it would have been a something different answer. Okay, because it is water, the density of water you can take it to be 1, and that is the mass of the displaced water, and this is gravitational acceleration. So g cancels. Okay, so X equals to, what is the rho I? Rho I is given 0.917 times V. Okay, the density of water, remember the density of water is 1 for gram per cc unit. Okay, for any other unit it is not 1, only for gram per cc unit. So this is 1. If they have given you kg per meter cube unit, then you have to convert it into gram per cc to solve this question. Be careful about that. Okay, so as we can see that X is directly 0.917 of the entire volume. So correct answer is option C, 0.917. Okay, question number 16. The pressure at the bottom of a liquid tank is not proportional to. So what is the pressure of a liquid in a tank? Suppose we have a liquid. Okay, the height is say h, the density of the liquid is rho. Okay, so what is the pressure? Pressure is h rho g, we know that, right? This is the pressure at the bottom. Okay, so obviously acceleration due to gravity, it proportional. Density of the liquid proportional, this is density of the liquid, so this is also proportional. Height of the liquid, it is also there, so this is also proportional. Area of the liquid surface, can you find area here? Any area is given here? Area is not given, so this should be the correct answer. So this is a negative type of question where you have to eliminate the incorrect option. Okay, so you have to check what are all the correct, and those will be eliminated, and then you have to find whatever is incorrect. Okay, whatever is not proportional. So be careful with such questions. Okay, where the question language is negative. Okay, so you have to do the opposite. Now question number 17. A closed water tank has cross-sectional area A. It has a small hole at a depth of h from the free surface of water. The radius of the hole is so that r is less than a by pi if P naught is the pressure inside the tank above the water level and Pa is the atmospheric pressure. The rate of flow of water coming out of the hole is is. Okay, so what is the answer? We know that flow rate. Okay, so they have asked you the rate of flow. Rate of flow is, suppose the rate of flow we are saying RF. Okay, so it is basically area times speed. What is the area of this hole? The radius is r, so area is basically pi r square. That much is clear. All the option has pi r square. Okay, and then you have to remember the expression for velocity. I told you 2gh plus 2po minus pa divided by rho. Okay, so this is the formula for velocity. The derivation is not required. If you remember this formula, you can answer this question. This question came twice in your previous year. So one of this question is this question, same question came once more. Okay, so if you remember it, you can answer this question. Okay, so that's why I say remember this question. And one more hint is that both the term has 2. Okay, if you check this here it does not have any 2. So that is one more hint. Okay, and obviously because even though the radius is very small than a by pi, okay, you cannot ignore this pressure difference. If you ignore this pressure difference, then it will be incorrect, because it is a closed container. If it is an open container, then you could have ignored atmospheric pressure. You can say PU and PA are same. Okay, so you can ignore this entire thing to be 0. Okay, hydraulic lift works on the basis of Pascal's law. So we have already learned that. Okay, now an ideal fluid flows through a pipe of circular cross section with diameters 5 cm and 10 cm. So the diameters in this case is 5 cm and in this case is 10 cm. Diameter means this is the diameter. Okay, 10 cm. Okay, the ratio of velocity. So ratio of velocities for fluid A and B. So suppose the velocity here is VA and the velocity here is VB. What we are trying to find? We are trying to find VA is to VB. Now what is the flow rate? Flow rate for both sides, if the flow rate is here is say RF, the flow rate will be same. Right, same amount of fluid is flowing through this, so the flow rate will be same, rate of flow will be same. So what is the flow rate for surface A? Surface A will be area A times velocity A, and since it is equal to area B times velocity B, we can simply, if we find the area of A and B, we can simply find the ratio of VA and VB. So what we are trying to find? We are trying to find VA by VB. That is equals to B by A. Cross multiply. Okay, so now what is BA? BA is pi RB square divided by pi RA square. Now what is RB? RB is diameter divided by 2. So diameter in this case was 10 and divided by 2. What is RA? RA, again the diameter is given by 5, so 5 divided by 2. Okay, so pi already cancelled, so it is very easy to calculate. Okay, so 10 by 2 whole square divided by 5 by 2 whole square. Now why I am not cancelling it here? Because these 2 is okay, this 10 by 2 is going to be 5, but in the denominator it will be 5 divided by, so it will give me a point. So instead of doing that, what I will do, both of them are divided by 2, so we can simply cancel these 2's. Right, so we can simply cancel these 2's, so we will get 10 square divided by 5 square. Okay, so 10 square is 100 and 5 square is 25, so 100 by 25 is 4, so it will be 4:1. So 4:1 is correct answer. Right, we have found the correct answer. Now next question. Okay, another question, another interesting question. A cylindrical container containing water has a small hole at a height of h equals to 8 centimeters. So the hole here is at 8 centimeter. So this is 8 centimeter. Okay, and from the bottom and from the depth of 2 centimeter from the top. So from the top it is 2 centimeter. Okay, the maximum horizontal distance traveled by the water before it hits the ground. So maximum horizontal distance traveled by the water before it hits the ground. So this distance is r. So this is actually kind of projectile motion. Okay, so what we will do, first we will find what is the speed. What is the speed of the outgoing water? So we know that speed of outgoing water, we have just written the formula. Okay, so it is basically square root of 2gh plus PO minus 2PO minus PA by rho, but in this case it is an open container, so for open container PO and PA are same, so we do not need to consider the PO and PA. So only thing that we need to consider is square root of 2gh. Okay, now here this h is this h, that is from the top. So let me insert the values, or okay, no need to insert the values right now. Okay, this is the velocity of the outcoming liquid or outgoing liquid. Now this is in the direction, this is in the horizontal direction, right? So this velocity is in the horizontal direction. So what is happening in this direction? Vertical direction. So in the vertical direction, initially there is no velocity. Okay, so what is happening? Initially there is no velocity, but there is an acceleration, just like projectile motion. Okay, like projectile motion, the water is having an attraction towards the ground. So what we have to calculate? We have to calculate how much time it will take for this water drop to reach. If you just drop this water from this height, how much time it will take for it to reach from here to here. Okay, so this time we have to calculate. How we can calculate? We know that this is nothing but half gt square. You remember this formula? This formula we applied for projectile motion, right? Yes, same formula. Here height is given already, so we just need to find the time. So t square is equal to 2h by g. Okay, so and from there we can find the time. Time is equals to square root of 2h by g. So this is the time taken by the drop if you just simply drop it from to reach from here to here. Okay, this is the time required. Now the same time there is a horizontal speed as well, so it is moving in this direction as well. So what is the range? To calculate range, if you remember, horizontal velocity times the time, total time of flight. So here we have already v is square root of 2gh times square root of 2h by g. So these both g's are inside the square root. One is in the numerator, another one is the denominator, so they can cancel each other. So we can simply write this as 2 times 2, that is 4h. Okay, so square root of 4 is 2, they will come out automatically. What is the value of h? H is 2 centimeter. What is the value of capital H? H is 8 centimeter. So it will be 2 times 16. So it will be 2 times 4, that is 8 centimeter. Okay, so it will touch the ground at a distance 8 centimeter from the base of the container. Okay, now let's look into the next question. Now from now on we have already completed gravitation, properties of solid, properties of fluids. Now we will be doing moving charges and magnetism part, question number 21 till question number 30. So let's see. A circular coil of wire of radius r has n turns and carries a current I. So what is the question? We have a circular coil of some n number of turns. Okay, each turn carrying a current I. Okay, and it has a radius r, radius small r. Okay, the magnetic induction B at a point on the axis of the coil. So magnetic induction B on the point axis of the coil, okay, at a distance root 3r from the center. So at a distance root 3r from the center is, so how to calculate this? We know that magnetic field for this case is given by mu naught Ni. So you have to remember these formulas: r square divided by 2 r square plus, say this distance is x square to the power 3 by 2. This formula is already there in your book, and this derivation is also there, so you have to remember this formula. Okay, the derivation is little difficult, you can try this derivation, okay, but formula is very important. Formula you have to remember it. Okay, so now let's start with the values. Let's insert these values of x equals to root 3r. That's it. If you insert the value of root 3r and then simplify, you can get the answer. So what is the value of b at this distance? So mu naught Ni r square divided by 2 r square plus root 3r whole square to the power 3 by 2. Okay, that's it. So mu naught Ni r square, some mathematics, formula part is only physics, otherwise it's simply mathematics. Now root 3r whole square, root 3r whole square means root 3's whole square is 3 and r whole square is r square, so it will be 3 by 2. Okay, so r square plus 3r square is 4r square. Okay, I am doing it step by step so that you don't miss out on anything. Divided by 2, so it will be 4r square to the power 3 by 2. Now this thing we have to simplify. What is 4r square? 4r square, we can write 4r square as mu naught Ni. So this will develop with more problem solving. 4r square is 2r whole square, right? And then we have to the power 3 by 2. So times 3 by 2. Everything is in the power, right? So these two and these two will cancel, right? So now we can write this as mu naught Ni r square divided by 2 2r whole cube, right? So the entire thing is now simplified. Now let's do the cube part. So we can write this as mu naught Ni r square divided by 2 times 2 cube is 8, r cube is r cube obviously. So now if you see there is a r square in the numerator, so we can simply cancel one r square with r cube, right? So there will be only one r left in the denominator, and 2 8 is 16, so it will be mu naught Ni by 16 r. Okay, so if you solve it step by step, you can get this is the answer. Okay, so this is a practice problem. You have to practice such questions based on the formula, and if you practice such problems, your mathematical ability will improve. Your physics will not improve. To improve the physics, you have to remember this formula. If you remember this formula, your physics is already improved. Okay, only thing that you have to develop this knack of solving this mathematics. Okay, you are solving similar mathematics in mathematics problems as well. So if you can solve the similar kind of situation in mathematics, then I guess you can solve in case of physics as well, right? Now let's move on to the next question. A proton moves with a velocity of 5 times 10 to the power of 6 joules meter per second, sorry, not joules, this is j cap. Okay, j cap meter per second through the uniform electric field E equals to 4 times 10 to the power of 6 2I cap plus 0.2 j cap plus 0.1 k cap volt per meter, and the uniform magnetic field of B equals to 0.2 times I cap plus 0.2 j cap plus k cap Tesla. Okay, so what is the approximate force acting on the proton? Okay, so I will going to teach you a shortcut method this time. Okay, I already solved this question once before, I think. Now today I am going to teach you one shortcut method. So as you can see that in this case the value of magnetic field is 0.2. okay, 0.2 is multiplier, and there is only one small value. This is also 0.2. So, and there is one more 1. Now magnetic field B, if you see, is very small compared to the electric field, because electric field is getting started with 4 times 10 to the power of 6. Okay, so the electric field is very strong compared to the magnetic field. So what we will do, because we are not interested, because we are only interested in the approximate value, not the exact value, first of all we will not consider this at all. Okay, if you see there are stark differences between electric and magnetic field, you don't need to consider magnetic field at all. You can simply ignore that. Okay, even the velocity is very high, you can simply ignore the magnetic field in this case. Okay, only thing that you have to consider is the electric field, because it is an approximation method. Okay, and once we approximate the value, then we will see which one is the closest one. Now what is the force? Lorentz force, we know that Lorentz force is Q times electric field E plus V cross B. Right, this is the formula. Okay, so what we will do, we will just simply calculate QE and we will find the approximate values. Okay, we can ignore this value. All the values given here are quite distant apart, so we will find the exact value very quickly. So let's see what is the value of Q times E. Q is a proton. So what is the charge of a proton? Proton's charge is 1.6. Okay, times 10 to the power of minus 19. Okay, now what is the electric field? Electric field is given in a vector form, but if we want to find the magnitude of force, then what we have to do, we have to multiply it with the magnitude of E. How to find the magnitude of E? To find the magnitude of E, first of all, this is a constant, so this we will write as it is. Okay, now A I cap plus B j cap plus C k cap, then we can write them as square root of A square plus B square plus C square. Okay, magnitude we are trying to find. Now in this also, if you see, we can simply ignore these two values. Okay, they are very small values. So we are doing approximation after approximation because we have to save some time. So 1.6 times 4 times, let me simplify this. Okay, 10 to the power of minus 19 plus 6, so 10 to the power of minus 13. Okay, and all the options you see, they already have 10 to the power of minus 13. Okay, now square root of 2 square, we are ignoring this also, so this will be only 2, so multiply by 2. Okay, and trust me, this is very close to actual value. Okay, if you have solved everything properly, then instead of 2 you will get 3 here. That's it, that is the basic difference. Okay, so now what is the value? 8 times 1.6, 4 to the 8. Okay, so you don't wonder from where, sir, you have written this 8, you have done some mistake. This is 4 to the 8, so it will be 8 ones are 8 and 4.8, so it will be 12.8 times 10 to the power of minus 13. Okay, because we have always reduced the values, okay, our answer should be more than this value. This is a reduced value because we approximated and everything we have cut, we have deleted, we have not increased, right? So this is a reduced value. Okay, that is how you should understand the correct answer should be 15. And in fact, in this case only the closest value to this is 15. So this is a very short way to solve this long question. Otherwise it will require you to do cross product, then add them, then again do this square root method. So this will take a long time to solve this question. But if you use slight brain of yours, that okay, this is electric field is very strong, we can simply ignore, because electric field has not only 4 times 10 to the power 8, b, even though the velocity is 5 times 10 to the power of 6, that means it is balancing the electric field. There is a multiplier of 0.2 with the magnetic field. So that is what reducing it by 10 times. So that's why we can simply ignore it. Okay, and if you solve it properly, then you will get very close to 15. That's it. Okay, and this value, instead of getting it as 2, you will get 3. That's it. Right? Now let's move on to the next question. Question number 23. A tightly wound long solenoid has n turns per unit. So tightly wound long solenoid. Okay, so long, very long solenoid. Okay, has n turns per unit length. The radius r, the radius of the solenoid is r. Okay, carries a current I. A particle having charge q and mass m is projected from a point on the axis and a direction perpendicular to the axis. So suppose this is a cross section. Now you are throwing a particle in this direction along the axis with the velocity say v. Okay, the maximum speed of the particle for which the particle does not strike the solenoid. So what will happen to the particle? So in this case, the particle will start rotating in a circular motion. Okay, because you are throwing it in the along the axis, it will either move like this or in the upper half. Okay, based on whatever direction of current flowing in the solenoid, so it will either move like this or it will move like this. Now what is the maximum radius this motion can have? What is the maximum radius, or what is the maximum diameter this can have? The maximum diameter it can have is r. Obviously the radius is given r, so maximum diameter is r, so maximum radius of this rotation will be r by 2. This is the basic understanding of this question. Rest is very easy. Okay, rest is very easy. So first what we will do, we will try to find out the force acting on this charge. So what is the force acting on this charge? Force acting on this charge is nothing but QVB. Okay, and that force should be equals to the centripetal force, that is mv square by r. Okay, from here it will be r by 2. Okay, because it is rotating in a circle of radius r by 2. From here we just simply try to find the velocity v. Okay, one of the v cancels, so v equals to qb times r by 2 divided by m. Okay, or qbr by 2m. Now what is the value of b for a solenoid? That you have to remember. So solenoid, for a solenoid it is mu naught Ni. That is the magnetic field for a solenoid. This is a very important formula, very simple to remember. So from here you can write q times mu naught Ni, there was one extra r here, divided by 2m. So you can simplify, or you can rewrite this as mu naught Ni qr divided by 2m. Okay, so if you see, all of them have same numerator, only denominator is different for this. Okay, so even if you don't calculate it, you can simply, after calculating up to this point, you realize that you can realize that there is a 2m in the denominator, so 2m will be the answer here. And here, because it is projected along the axis, you have to understand that the radius will be r by 2 and not r. That is the basic understanding of this question. Otherwise this is a very simple question. Okay, now let's move on to the next question. Which of the field pattern given below is a valid for electric field as well as magnetic field lines? So first of all, we will cancel whatever is not valid for magnetic field. So for example, for magnetic field, this is not valid. okay, because this is only for positive charge. Magnetic monopole does not exist. Okay, this is also not valid because again magnetic monopole does not exist. This is partially correct, but here as you can see there is no internal line shown here. So internal line shown means the lines are only going from in to out, but it is not forming a proper closed loop. If there was an arrow in this case, then that would have not been possible for electric field, but may be possible for magnetic field. So this is also not possible. So only possible answer is this. Now we know that magnetic field lines are closed. So magnetic field lines are closed, so basically this is possible for magnetic field lines. Okay, but this may be possible for magnetic field lines, but the internal arrows are not shown. So we are not clear, so we can ignore that. Now when this is possible for electric field, for induced electric field, if you keep suppose you have an object, okay, if you have an object and if you bring some externally charged object, say this is plus plus, then it will induce a negative charge on this side and a positive charge on this side. So in this case, this magnetic electric field due to this object will be closed loop. Why? Because there are bound charges and total amount of positive and negative charge are occurring here. So you can consider this to be possible for induced charge. Okay, not for this charge but for this induced charge. Actually it is a neutral object, so you can still get electric field and that will give you a closed field for induced object. Okay, induced electric field. Now next question. In the given figure, the magnetic field at O is. So what is the magnetic field at this point? Very interesting question. First of all, what we will do, we will find the magnetic field due to this circular complete. If the circle was complete, this is little difficult question, but this question came in your previous year, one of such previous year in your KCET exam, so you cannot ignore it, even though this is slightly difficult, slightly JE level question, but not super difficult. Okay, so first of all what we have to do, we have to imagine that entire loop is closed, entire circle is closed. Then what would be the magnetic field at the center? So we know that magnetic field at the center is given by at some distance. If you remember, only one of them will be sufficient, that is mu naught. Here this is only one coil, so no n is required. Mu naught, otherwise it is Ni. Okay, radius is given here r, mu naught Ni r square divided by 2 times r plus x whole square, r square plus x square to the power 3 by 2. I hope you remember this formula. I just used it few problems back. Now in this case we are finding at the center. So at the center means x is equals to 0 in this case. Okay, so x is equals to 0 means what we get? We get simply r square to the power 3 by 2. Now r square to the power 3 by 2, again this 2 and this 2 will cancel. So we can write this as mu naught I r square divided by 2 r cube, right? So this is 2r cube. Now r square and this will cancel, so you will get mu naught I divided by 2r, right? Either you can remember this formula or you just remember the one single formula, mother formula, and then you find it. Okay, so I generally find it difficult to remember all the formulas, so I just remember this mother formula, and based on the problem I just put the x equals to 0, but it takes slightly longer than usual. Okay, but this formula is, I feel this formula is more important, and I can derive this formula anytime I want. It takes maybe 10 seconds. Okay, if I am doing it during the class, it is taking a little longer, but when I do it on my own, it takes hardly 10 seconds. So 10 seconds extra I can save if I remember the formula. For example, if you are preparing for NEET, you have no other option but you have to remember all the formulas, because in NEET every 1 second counts. For KCET you can have slightly extra time, there are enough time given to you, so you can take slightly relaxed approach. Okay, so this is mu naught I by 2r. Now that is for the entire circle. Okay, this is for the entire circle. This is why this problem is slightly difficult. Now if you see, there is 1 half, 2 half, 3 half, 4 half. Okay, so you can divide the circle into 4 equal parts. Okay, for 4 equal parts, this is the magnetic field. But here this part is missing. This part is missing. So this part is missing means actually how many parts are there? This part is missing here. So this part is not contributing any magnetic field. So how many active parts are there? 1, 2, 3. So the actual magnetic field will be 3 by 4. So 3 by 4 means why? Because if there are 4 parts, 4 by 4, you will get the full magnetic field. But because only 3 parts are there, so you have to use mu naught I by 2r. So you will get 3 by 8 mu naught I by r. Okay, now if you solve up to this point, this problem is easy. Okay, so if you see in this options, all the given options, only 2 of the options are given like this. Okay, now if all of the options are given like this, now here there is a magnetic field due to this. Here is, if you consider this wire like a long infinite wire carrying a current in this case, okay, then this will also have a magnetic field. Right, now what will be the magnetic field? Now for a circular coil, this is the direction of magnetic field. Okay, now for a straight wire, this is the direction of magnetic field. So if you remember the direction of magnetic fields, you can solve this question without even understanding, without even solving the question, you can guess that. Okay, I will tell you the method to guess the answer for this question. Okay, so this is the direction of current in this case, and this is the direction of magnetic field due to the straight wire. So basically what is the point of this? Both of them are into the paper. Both of them are into the paper. Okay, into the paper. Into the paper means what? They are getting added. Plus sign should be there in the middle, right? So both the electric field due to this magnetic field due to this straight wire, magnetic field due to this circular coil, they are both in the same direction. So basically they will add up. Okay, so they will add up means the correct answer should be this, not this. Both of them have the same sign, only thing this is plus, this is minus. But minus is not possible because the magnetic field is getting added up. Okay, magnetic field is getting added up in this case. That's it. Now how can you guess this problem even without solving it? Okay, so if you see among all the options, these 2 options are exactly equal, but there is only negative sign is different. Okay, in this case these 2 values are different. Okay, so they will only try to confuse you whether it will be plus or whether it will be minus. Okay, so you just don't need to solve this question. If you see these options, you can easily guess that the answer should be between these 2 options. Okay, because if you see here also mu naught by I by 4 pi, mu naught I by 4 pi r, mu naught I by 4 pi r, mu naught I by 4 pi r. So the second part of all the 4 options is same. So you don't even need to calculate this value. Even if you calculate, you know it will be mu naught I by 4 pi r. But whether it will be plus or it will be minus, that is the question. For that you have to have the knowledge of how to find the direction of magnetic field when it is moving in a circle, when it is going in a straight line. 2 different approaches you have to know. So in this case, if you follow the arrows through your fingers, and then your thumb will point the direction of magnetic field. That is for circles. Okay, for circles you curve your fingers and your thumb denotes the direction of magnetic field. And exactly opposite method for straight wire. For straight wire, you point your finger in the direction of current, okay, and then wherever your fingers are pointing, that will give you the direction of magnetic field, right? So if you find out that, if you see both cases, this is also into the paper and this is also into the paper, so they will basically add up. So between these 2 options, this is the correct answer. Okay, this could have been the correct answer, but because they have given the option such that this is also 3 by 8, this is also 3 by 8, so most likely this is the answer. But you have to be clear in your calculation. That's why I have calculated the first part. It could have been 3 by 4 as well, so people may be confused whether it will be 3 by 4 or 3 by 8, so that's why I have calculated the first part. Second part is same for all the part, so you don't need to calculate, only you need to find the direction and then you can find the correct answer. Okay, so if you want to guess such questions, such difficult questions, you have to understand it. Okay, you cannot blindly guess any questions. Okay, without doing mathematics you can solve this question, but your guess should be based on scientific determination, scientific evaluation of the question. Okay, so that's why I have explained how you can guess this question as well. Now let's look into this question. A circular current loop of magnetic moment M is an arbitrary orientation in an external uniform magnetic field. The work done to rotate the loop by 30 degrees about an axis perpendicular to its plane. So there is a circular current carrying loop. Okay, there is a plane perpendicular to this and it is rotated. It is some arbitrary angle with some external magnetic field B. Okay, so now you rotate it. Suppose this is a current carrying conductor, you rotate it like this. Okay, so you are rotating, this is a circular coil. Now let's look it in from this direction. You are rotating like this, so there is already a current flowing in this and you are just simply rotating like this. So if you rotate it in this direction, what is the direction of the magnetic moment? Magnetic moment is in this direction due to the current carrying loop. Okay, and the torque acting on it is basically M cross B. Right, now if you see the direction between magnetic field, magnetic moment and magnetic field is constant, as it is only rotating around this axis. Okay, this angle will not change. This angle will not change means the change in the magnetic moment will be 0. Okay, so it will be 0. So in this case 0 is the answer. Okay, so the work done will be 0. Work done will be 0 because the torque will be 0. So torque 0 means work done is 0 in this case. Right, work done is torque times change in angular angle. Right, we learned that in our rotational motion chapter. We have already completed that chapter. So work done is torque times angle theta. So here theta is 0, theta change in theta is 0. So we can say that this is 0. Now 27, a charge Q is accelerated through potential difference V. It is then passed normally through a uniform magnetic field where it moves in a circle of radius r. The potential difference required to move it in a circle of radius 2r. So first of all, when you are moving a charge Q in an potential difference V, what is the energy of that particle? The energy of that particle is given by Q times V. Right, force is Q times E, energy is Q times V. Right, now when it is coming out of the potential, then what is had? It has a velocity. So what is that velocity? V, suppose small v. Then what is its energy? Its energy is half m small v square. Right, kinetic energy, entire energy is kinetic energy when it was initially in the potential field. So its entire energy was potential energy. When it is coming out of the potential field, its entire energy is kinetic energy, and from the conservation of energy we can write this potential energy should be equals to kinetic energy. Right, so from here we can calculate the velocity. So V equals to 2qv by m whole square root. Right, so this is the basic thing. Now let us try to go back to the equilibrium condition, that is mv square by r. The centripetal force is equals to the Lorentz force, that is qvb. Okay, so this is the main thing. And from here we just need to calculate the value of v again. So v equals to qb r by qbr by m. Right, these two velocities should be equal. these two velocities should be equal. So we can write that q br by m equals to 2qv by 2q capital V by small m. Okay, so everything in this equation is constant and only thing that is changing is this r and this v. Okay, so we can say that r is basically proportional to square root of v, right? Or you can say r square is proportional to v, right? So initially, or let's keep it like this only. Let's keep it like this only. Okay, now initially the radius say r1, final radius is r2, then it will be v1 by v2. Okay, so first case, sorry, square root. So first case the radius was r, the final radius is 2r. So r divided by 2r equals to v divided by v2. We are trying to find this v2. Okay, so this r cancels, so 1 by 2. Okay, or let me write it here, v by v2 square root equals to half. So now let me square it. If I square it, then what I will get, this square root will be gone, and here in this side I will get 4. Okay, so if we square it, we will get 4. So from there just do the cross multiplication. So we will get v2 equals to 4v. So we need 4v potential difference. Okay, so this is slightly difficult question, but you should remember that because it's either will be inversely proportional or directly proportional, these options will not be possible. Okay, these 3 and 1 odd answers will not be possible. It will either 2 or 4. Okay, so this is simple. Now question number 28, the magnetic field at the center of a current carrying loop of a loop of radius 0.1 meter is 5.5 times that at a point along its axis. The distance of this point from the center of the loop is. So if you remember, we have already calculated the magnetic field on the center of a current carrying loop. So what is that? So it is mu naught I by 2r, right? So mu naught I by 2r is the magnetic field at the center of a current carrying loop. There was some n, you can write that as n, but n is not required here. And on some point on the axis, it is mu naught I r square divided by 2r square plus x square to the power 3 by 2, right? So this is the formula. These are the two formulas that you can remember, right? So these are the two formulas, but if you remember only this, put x equals to 0, you will get this value. Okay, so it is very hard to believe that this complicated formula, if you put x equals to 0, the formula becomes so simple, right? Now it says that there is a radius, everything is given, but it says that at the center whatever is the magnetic field, okay, and it is 5.5 times at a point along its axis. So b equals to 5√5 times bx, that is given. Obviously at the center it will be maximum value. So now let's put these values and try to cancel as many values as possible. So mu naught I by 2r equals to mu naught, obviously 5√5 will be there, mu naught I r square divided by 2 r square. So this is just a mathematics. As soon as you have written down these two formulas, rest part is simple mathematics. Okay, but obviously they don't give you want to give you the food exactly in your mouth. You have to chew it, right? You cannot have food directly into your stomach. right? You have to chew it, then gobble it so that it goes to your stomach. So that part you have to do. Now do the cross multiplication. Okay, this will go here and this lone r will go here. Okay, so we will see that r square plus x square to the power 3 by 2 equals to 5 root 5, okay, r cube. Okay, so this is the basic thing. Now what we can do, we have to eliminate this 3 by 2 from both sides so that I can solve it. So to solve that, what we can do, 5 root 5 I can write this as square root of 125. How? 5 root 5, that is square root of 25 times 5. Okay, so 25 times 5 is 125, right? So that's why I have written it 125. And r cube, I can write this as r square to the power 3 by 2. Law of indices, we can simply cancel these 2's. So I have only squared it and then I divided it, right? So, and 125 can be written as, this can be written as 5 times 5 times 5, right? Or this can be written as 5 cube divided by 2. Square root means divided by 2 and 3 5's are there, so 5 cube, right? So this can be written as 5 to the power 3 by 2 r square to the power 3 by 2. So, or we can simply take them common, the 3 by 2 power, and I can just write 5 r square to the power 3 by 2. Now both sides have this 3 by 2 now, so we can take that appropriate square roots and we can cancel these 3 by 2. So we can write this as r square plus x square equals to 5 r square. So these 3 by 2's are cancelled now because both side has same power, right? So, or we can write this as, let me write it here. From here we can write x square equals to 5 r square minus r square, that is 4 r square. Okay, so x equals to 2r. X equals to 2r. So r was 0.1, so x will be 0.2. Right? So 0.1 was r, so x will be 0.2. Clear? Now, this is slightly complicated but not super if you have understood the problem. Everything I have done is here is mathematics. Only physics is this. This is the only physics that you need to remember and understand the problem and write it in the mathematical term. Then just mathematics, no physics. Have I used any law of physics in this part? Nothing. It is mathematics only. Yes, mathematics is not super simple but not super difficult as well. Okay, if you practice 2-3 times, you can solve such questions. Now, question number 29. The torque acting on a magnetic dipole placed in an uniform magnetic field is 0. What is the angle between the dipole axis and the magnetic field? So, I just wrote the formula for torque. Okay, torque is basically magnetic moment times magnetic field, right? So, the magnitude of torque is mb sin theta. Now in this case what is said that the torque acting is 0. So torque acting is 0 means this is 0. Now m cannot be 0, b cannot be 0, so only thing is sin theta has to be 0. So when the sin theta is 0, sin theta is 0 when theta is 0. Okay, if it was a dot product relationship, then there would have been cos theta. So cos theta it would have been 90 degrees. But because it is a cross product relationship, so sin theta will come and it is 0 when theta equals to 0. Now question number 30, last question of the day. A proton and an alpha particle moving with the same velocity enter a uniform magnetic field with their velocities perpendicular to the magnetic field. The ratio of their circular paths. Okay, so we are solving some questions based on this, right? mv square by r is equal to qvb. Okay, so from here we can simply write r equals to, one of the v's will cancel, mv by qb. Okay, so mv by qb is the radius of the circle. Okay, now it is said that a proton and an alpha particle. What is the relationship between a proton and an alpha particle? First, find the in case of proton. So for proton, mass is mass of proton. Okay, velocity is constant for both the particles. Charge of a proton is plus e. Okay, electron is minus e, so proton is plus e, plus eb. Okay, so this is the radius of a proton. Now for an alpha particle, okay, mass of an alpha particle is basically 4 times mass of proton. We already know that, right? There are 2 protons and 2 neutrons inside a alpha particle, so its mass is basically 4 times that of mass of proton, and its charge is basically 2 that of proton. Okay, so 2e. So now what is the R alpha? R alpha is m alpha v divided by q alpha b. So that will be 4 mp v by 2 eb. Okay, or it will be cancelled, so 2 mp v by eb. So that is equals to rp, so 2 rp. So what is the relation? The ratio of radii of their circular paths is, so first we have proton, next we have alpha particle, so it is rp by r alpha, that is 1 by 2. Okay, so alpha is more, so alpha will be denominator, so it will be 1:2. So answer will be 1:2. Okay, I hope you enjoyed today's session. If you enjoyed our session, don't forget to join our WhatsApp channel and subscribe to our channel. Okay, the link to the WhatsApp channel is given in the description, and I will be back with a new lecture tomorrow. Till then, bye.